Welcome to Unit 5B, Extending Quadratic Functions. This unit has 5 skills. Currently skill number 48 is the first skill. I can solve quadratic equations with complex roots, and that's the skill we will be focusing on today. We'll be starting our notes on page 48A. We number our notes by the skill number so that if we want to add to our notes in class, we can add notes beyond the extent of what I cover in class. So 48A, B, and C will be today's notes, and if you want to add to them in class, 48, D, E, F, etc. Alright, the first thing that we're learning is the imaginary unit, I, and it's represented with a lowercase I, and it is equal to the square root of -1. This was created because previously we had no method for solving a problem like the square root of -9. 3 squared equals 9, and -3 squared equals 9. So we needed to generate a way so that we had some number times itself equaled -9. And so a mathematician generated the imaginary unit, which is equal to -1. I've given several examples of imaginary units down here and how to simplify them. So the square root of -25 we can say is equal to I root 25, which is I times 5. And then finally, I is treated similar to a variable in the sense that it comes after a number. One possible way that this pops up is when we are trying to solve a quadratic equation. Here's an example of a quadratic equation, and you see when we subtract 56 from both sides, we get -56, then we divide by 7, and then we take the square root. And because the square root of -8 was previously unavailable to us, we take the square root and we use the imaginary root. So the square root of -8 is equal to I times the square root of 8, which is equal to I times the square root of 4 times 2, which is equal to 2I root 2. We need to keep in mind that anytime we take a square root, we use the plus and minus. We also have what's considered complex numbers, and complex numbers are part real and part imaginary. So if we said, well, here's the number 7, that's a real number, but we want to add some imaginary element to it. So 7 plus 2i. What you're saying is 7 plus 2 times the square root of -1. I've listed a few examples of complex numbers, and then I've created an example for us to use on how this will be used on the skill test. We're given an equation 3x plus 25i is equal to 21 minus 10yi, and we need to find out the values of x and y that make the equation true. Forgot a word there. Okay. So what we can do is, because both of them are in the form of a plus bi, 3x plus 25i is a plus bi, and 21 minus 10yi is a plus bi, what we can say is the left-hand a is equal to the right-hand a, or 3x equals 21, which means x equals 7. We can also say that the left-hand bi is equal to the right-hand bi, or simply b equals b. So we have 25 equals -10y. If we divide both sides by 10, we can find that y is equal to -25 over 10, which reduces to -5/2. Finally, the complex numbers allow us to solve quadratic equations or find the zeros of quadratic functions as demonstrated here by using completing the square. In step one, we took the constants and moved them to the left-hand side of the equation and kept the variables on the right. Step two, we factored the x squared coefficient down to 1, so we pulled a 5 out. 5 times 8 is 40. Step 3, we completed the square. So half of 8 is 4, and 4 squared is 16. And because we added 16 5 times to the right-hand side of the equation, we need to add 16 5 times to the left-hand side of the equation. Step 4, I simplified the left-hand side and then wrote the perfect square trinomial on the right-hand side. Step 5, I started solving. So I divided by both sides by 5, and then I took the square root of both sides. And the square root of -2 is I root 2. Once I found the plus and minus I root 2, I subtracted 4 from both sides. And this gave me the 2 roots of the function, the 2 zeros. So this number could be plugged into the function and give us an answer of 0. These 2 roots are called complex conjugates. And complex conjugates is actually a really easy concept to understand. The complex conjugate of a plus bi is just a minus bi. So our 2 plus 5i became 2 minus 5i, and our 7 minus 8i becomes 7 plus 8i. So the only thing that's changing is the negative sign becomes a positive sign, or vice versa. So quadratic equations with real coefficients and non-real roots have roots which are complex conjugates. Alright, for skill number 48, the skill test will consist of several different types of problems. One of them is pretty much straight up finding the square root of a negative number. Second of all, we should be able to solve quadratic expressions or quadratic equations that will result in negative roots or imaginary or complex answers. The third thing that we should be able to do is, like one of the final examples, if you had 3x plus 7yi, and you have to equal that to 21 minus 14i, solving for x and y. And then finally we should be able to find the complex conjugate of, say, 3 plus 2i. What is the complex conjugate of that? All right, thank you.